And this is a term that comes up quite a bit whenever we're talking about any sort of code. It's the term modality. And I'm going to say this term quite a bit because I feel like the introduction of modalities is where we see churn in our code. And now that I've mentioned another term, churn, let's talk a little bit about the problem that we're facing when we have reports that just don't seem to be a satisfying experience. It seems like we're constantly going back to them. Let me show you an example. Here is a very simple report that I have. I have some data file, nums.txt. I'm going to load up every element. I'm going to sum them up. I'm going to figure out how many elements I have, and I'm going to report the mean value. And the mean value here is 101. Kind of makes sense. This data was drawn from a normal distribution with the location around 100. It's very likely that this is a very useful report. Maybe these are financial numbers and somebody says, oh, the average profit that we made per unit is 101. The average number of times that a user purchased something was 101.29 times. Then the average number of times a user clicked on something was 101 times. And if this report is useful and if the data is something that we want to look at, it's very, very clear that somebody will come back and say, well, you know what? I want to know a little bit more. I want to know what the largest and the smallest value was. It's not helpful for me to just know what the mean is. Even if I want to plot this, I kind of want to plot what the outliers are. And that's going to lead us to rewrite the block of code that we wrote. We're going to have to add some variable to store the largest and the smallest. We're going to have two if clauses here. And in addition to computing the total and the count, we'll try and figure out what the largest and the smallest value is. And then we give them our report and we say 101 was the mean, the smallest value was 119, and the largest value was the largest value was 119 and the smallest value was 76. And if it is the case that we have a little typo here, we can address that. Now, note one thing with the typo. This change to the report was actually fairly non-invasive. I just tried to change something at the very tail end. I didn't have to rewrite any code that I'd written before. When we talk about churn as being one of the sources of frustration that we have anytime we write reporting code, what we're talking about is this process where some code that on face seemed to be complete, seemed to be good enough, is being revisited over and over again. And every time we revisit it, we're doing something to mess it up. And if this code is used commonly, we may be invoking or we may require some sort of revalidation. You made a change to that code, revalidate that that change didn't affect somebody else's work. And it ends up being very difficult as these scripts become larger and larger and larger for us to tolerate that kind of churn because the dependencies, if we change one line up here, how many things could it break later on? Especially if this is not just one script, but library code. Well, this is what we mean when we talk about churn, because it never ends at just the mean and the smallest and the largest. The person comes back and he says, that report was so useful. Can you also tell me the 95th and 99th percentile? And also, while you're at it, give me the standard deviation. And when you think about it, if we had to go back to this code and we had to compute the P95 and the P99 and the standard deviation, well, this block of logic is just going to get more and more and more complex, and there is no end in sight because the moment they ask for the standard deviation, you know in the back of their head, they're thinking, once they give me that answer, I'm going to ask for the skew. And once they think that they've done everything that I've asked for, I'm going to ask for the kurtosis. And once they give me the kurtosis, maybe I'll ask for the fifth moment just to make their life miserable. Well, what you could think is, if we had written this report better from the start, we could have answered all of those questions, still requiring changes to our work. But instead of those changes being very disruptive, being this churn style change, they're changes that are more superficial. If instead of processing the data during the data loading, we just collected the data itself, turned all of this textual data into floating point values, and then computed each one of these answers, well, if they asked for the mean and we didn't have anything else, this is the mean, just the sum of the elements divided by the length of the elements. When they ask for the largest or smallest, it's just the min or max of the data. When they ask for the standard deviation, it's just the numpy.std. When they ask for the P95 or the P99, it's just the numpy.percentile. And what you can see here is we are able to solve every problem that is put in front of us, but the code is shorter, the code is simpler, and it's more flexible too. When they come and they say, you know what, I want the P90 as well, it's just a one-line change that does not affect any previous code, therefore does not require that we revalidate anything that was depending on this data set. We have now isolated that change and we have some better code. And when you look at this example, you might say, that's a little bit hokey. It's a little bit phony baloney. Is it really that easy in practice? But in fact, it is the case that we run into these real problems where It is genuinely hard for us to accommodate that churn, and better approaches genuinely do make it that easy for us to accommodate that churn in practice. One of the big areas where this comes up is around the idea of modalities, specifically modalities associated with the loading of data. One of those happens to be, what happens if the data is not clean? What if it needs some kind of cleaning? Well, here's another data set, but the data set has a couple of things that are not quite regular anymore. It's no longer just one value per line. Now there's some commented out values that you're supposed to skip over. Now there's a couple of values that have an extra decimal point at the end. Now there's a couple of values that have some spaces around them. And when you think about that, you might say, ooh, this is going to require a little bit more code. And when you think about the code that it might require, you might even need something like regular expressions in order to identify, is this one of the commented out lines, therefore I'll skip it, or is it one of the number lines, in which case I'll extract the portions that I know I can convert to a floating point number, and I'll ignore any extra noise that's on that line, like a trailing decimal point might be a consequence of some data writing issue. When you think about it, you really don't want to rewrite this code. You really don't want to have everybody rewriting this code from scratch. You really want to put this code into some place where people can put a dependency on it, where they can say, oh, I'm just going to use the data logic that somebody has already written for me because I do not want to write those regular expressions and try and figure out how to write them correctly from scratch. And so what this is likely to actually look like is you write some load data function and you tell anybody, anytime you're working with this data set that needs cleaning, just use my load data function. It does all the work for you. You don't have to worry about any of those details. And in your script, you have some if name equals main block, and you use this load data function to load it up. And then when you need to answer your questions, we have 48 elements that we're able to load. This is the smallest and the largest element, and we can import from the statistics module or from NumPy things like mean or standard deviation or percentile, and we can compute all of those as well. And this is the general pattern that we see quite a bit. Somebody has some complex data loading, and there's some additional reporting that we need to do. We need to get that reporting right. We need to get all the steps leading up to that reporting to minimize churn. But there is a problem with this code that we've written here. Anytime we're interacting with the outside world, we know that tends to be a source of churn, separate from the requirements on the reporting that we have. The dirtiness of this data could change very readily. The way in which we denote a comment, it may go from one commenting style to another. It may go from one data format to another. And it turns out that this code that we've written here is probably not right. Taking all of the data loading and putting it all into one function that everybody has a dependency on then means that if somebody else needs the data cleaning portions, but they have a difference in how they do the data loading. For example, the data is in another format. The data is in XML format instead of in plain text format. Then there's no way for them to easily dismantle this logic, so they're going to end up adding a flag like XML equals false and a switch in here. If XML, then you do something special to XML. Otherwise, if not, you use the plain text logic in order to load this just from a file with one number on each line. And this is what we mean by modality. The idea that later on we grow these choices, these options, XML or not XML. And oftentimes these are imposed upon us. Do I clean the data? Do I not clean the data? Do I include outliers? Do I not include outliers? What are the steps in the order of those steps? And this ends up creating churn deep in our code that requires revalidation. And when we try and write this code to do this a little bit better, one of the things that we might discover is maybe we want to isolate the parsing of the data from the loading of the data. Maybe we want to leave certain aspects of our code very superficial, like the actual loading of the data. Here, notice we can load from plain text and we can load from XML, and we can parse data using the same parsing function, even though the data loading is very different. And in this case, we have all of that flexibility that we've lost coming back. Now, it turns out that Python is very well suited to writing better reports if you lean into the approaches that we're encouraged to use in Python, things like object orientation, things like iteration helpers. And I very briefly want to run you through a couple of examples of where Python and the structure of the language and the guidance we get from the language actually lead us to writing better reports. Here's the first one. How does object orientation and the key argument for things like min, max, and sorted support better reporting? Well, the scenario is, instead of having one number per line, we have some entries. We have some date, some name, and some values associated with them. And it makes sense that somebody's going to want to print these out in some sorted order, maybe sorted by value, by the name, maybe sorted by value 1, maybe sorted by value 2. Somebody's going to want to do some minimization or maximization. What's the entity which happened to have the largest value 1? What's the entity which happened to have the smallest value 2? And the approach that we might take in order to load this up is we might use the absolute bare minimums of object orientation, something like a data classes.data class or a name tuple, collections.name tuple, to put this data into some structured format such that when we need to actually perform operations on this, we can perform operations on this structure type, and we can answer useful questions, not what is the largest value 1 or the smallest value 2, but what is the entity which happens to have the largest value 1 or the entity which happens to have the smallest value 2. So here you can see our data loading is really just putting this into a structure type. And we can move our logic around a little bit. We might make the argument that it makes a lot of sense for the data loading to be close to the type itself. So we use a class method in order to implement this. And once we do that, we might say, okay, now that we're ready to do some analysis on this, we might use the min or the max function, the sorted function, and this special key argument to avoid the decorate, sort, undecorate pattern that exists in other languages, or to avoid some complex data transformations that we might have to do using comprehension syntax. Instead, we just say, I want the maximum subject to the criteria of whatever this key function happens to be. I want the minimum subject to whatever this criteria happens to be. And you can see where this structuring makes this very readable. I also want to briefly share with you where things like generator expressions support better reporting code. It may be the case that when we're dealing with some data, here we have some data that has some tagging associated with it. So we have a bunch of different tags associated with this data. We're going to load it in. We have some entries. So for each entry, we have a tag. And we might want to do some sort of aggregated analysis, like what were the sum of all of the values that we had on a per tag basis. And when you look at the tags, you can see something interesting. Probably this tag here and this tag here are the same thing. They haven't been normalized. Probably this tag here, there's a little bit of data messiness that's probably the same as this tag. And the skip tag we probably need to skip. So when we see some code like this, and when the data set may change to introduce this messiness, we might have to add that data cleaning back in. And knowing that we want to extract from our data loading logic how we do the parsing, we might write a parse function that just takes the entries from whatever they've been loaded as and case folds them, strips off any white space, and skips storing them if the entry happens to start with a comment character, and then otherwise categorizes them. And when you look at this, you can say, okay, we managed to do the data cleaning that we wanted. We skipped the entities, we normalized everything, and everything's great. Except one of the modalities that's going to creep up here is, how do we know that the normalization, that the data cleaning has to happen in this particular order? You can think that under certain circumstances, if the skipping logic was something like skip if it starts with a hash or if it happens to be a particular tag, then we might have to add some modality here like the tags that we skip. And by default, we might make this, say, an empty frozen set, or just an empty set, and here we might say if the tag doesn't start with that, or the tag is not in the skip tags, and maybe this should probably be an and here, something like that. And then here we have to actually thread through that choice that we want. So here we'd say, okay, I'm going to skip that tag called up. So I'll put this into a set. And what you can think is, well, how do I know if this is lowercase up or capital up? How do I know if it's up with spaces around it? There's an ordering dependency here. And I just happen to get lucky that I already did the normalization for the tags before I checked these. But you can think that there could be circumstances where you need to do the normalization at different error. So these modalities arise all the time. Sequencing modalities, these kind of optionality type things. And our code isn't really set up to minimize that churn, because you can see just to skip specific tags, we had to change this code, which may require revalidating or writing new unit tests, any code that depends on this code. And so what we might think about doing is leaning into the guidance that Python gives us. Maybe instead of writing one massive for loop, we write multiple different for loops. We decompose this for loop into separate steps. We do the case fixing, the stripping, and the skipping of certain elements, and then the categorization separately. And it doesn't quite solve our problem because we still have a fixed ordering here, and we still need to add in that modality if we want to be able to specify certain tags that are skipped. But you can see this is pushing us in a particular direction because each one of these portions here is really just building a list by iterating over something, and we know we have specific syntax for that in Python. The syntax we have is comprehension syntax. So we could rewrite this again using comprehension syntax, and now you can see that the ordering is at least clear. Previously, we had a fixed ordering for the normalization steps, but we couldn't quite see what that ordering is. Here, we still have a fixed ordering, but we can actually see what that ordering is. We can see it's fixing of the case, then the stripping, then the skipped elements, and then the categorization. And at minimum, we've made our code a little bit easier for somebody to use and to understand because they know what the ordering of these elements are. But we could push this a little bit further and say, you know what, I'm doing a lot of looping over the data, and I'm re-looping over this over and over. And so if I had a billion elements, I would visit every one of these elements once here, once here, once here, and once here. Maybe I don't quite like that because that's going to be probably 4 times slower than visiting each element once. Or if this data happened to be very large, but as a consequence of how many elements I skipped, these two are enormous, but the actual remaining elements after skipping them was quite small. You can say I'm doing a lot of extra looping, and I'm also storing a lot of stuff that I end up throwing away. So I might turn this into a sequence of generator expressions. And one of the nice things about generator expressions is not only have I linearized the ordering of these steps, and it's very clear to see first you do the case fold, then you do the strip, then you do the skipping, but also I fuse this into one loop. Now, one of the things I know about comprehensions is I cannot do it for the categorization. One of the rules of the comprehension is you cannot change the thing that you're building while you're building it in the comprehension syntax, and this is the essence of what I'm doing with categorization. I'm updating some entry that I have while I'm building all the entries, and so it's necessarily the case that this has to be a regular for loop, but at least these 3 steps can be this comprehension syntax. And when I do that, I say, you know what? What if I further decompose this into 4 functions, and I allowed my end user to assemble them in any order they want in their code? And if I know that there happens to be a particular standard order, maybe I write a standard parse on the entries that makes their life a little bit easier. But I give them the ability to decompose these and to reorder them to their heart's content. And you can see certain modalities are still kept, like the skipping modality, but you can see where I'm beginning to isolate and extract my code, which will result in reduced churn because when I change the code for how I skip this, I don't have to revalidate anything that involves the categorization. Whereas previously I did because they were all part of one giant block. And I probably don't have to really ever revalidate this because this is just the composition of those 4 elements. This can be a very simple smoke test. It doesn't have to be a full-fledged unit test. I want to continue on this idea of iteration helpers. How do iteration helpers support better reporting? One of the things that we see is Python really pushes us in the direction, if we really pay attention to how Python wants us to write code, in writing code that leads to better reports. Let me set up another scenario for you. We have now some elements where we have some tag and some initial value, and you can see there's a little bit of data cleaning here. We need to skip elements and whatnot. And hidden in this code, I skipped the header line. You can see here that I said at the very top of the data set, there's a header line. And if I don't include this line here, I get an error saying, oh, I can't parse this header line. It's very common CSV files. They'll indicate what the fields are. And the way I sorted this out was by using one of the built-in iteration helpers we have, the enumerate. And I have a line here that says, if I'm looking at line number 1, just skip it, skip our headers. Well, we are very familiar with iteration helpers that are in the built-ins. Enumerate is one example of them, zip is another example of them, and they're things which help us as we do enumeration. One of the things you might think about for reporting is often, or is generally about visiting every element of a collection and either transforming it or performing some aggregation on it. That's a large part of reporting, is either these kind of grouped aggregations or some sort of transformation. Looping is critical to the idea of reporting. So writing better loops means we can write better reports. Let me show you an example. If I didn't know about enumerate, this is the code that I would write. I would have to have some variable called line number that I update here, and I could easily forget to add this line of code here, in which case my logic is wrong But you can see if I actually do data.append tag with value, I don't see any error. I just don't get any data. So here, if I do this, if I forget to add that one line, I get the worst of both worlds, which is an incorrect answer, but no indication it's an incorrect answer. It's very easy if I convolve the logic for managing the loop with the logic inside the loop that does the actual business task that I want to do, like the parsing of the data. And so it's clear why I want to use things like enumerate, but it may not be clear how I generalize this example beyond things like enumerate. Well, let me try and generalize the example of skipping headers. One thing that I could do to skip the headers is I could say, you know what, if I like things like enumerate so much, and I like the idea of these iteration helpers making my loops cleaner, why don't I make this loop here even cleaner and eliminate the skipping of this header, this line here, so that the only thing in the body of this loop is the actual processing. So I'll write an iteration helper called skip headers. They'll just go through every line and identify if I keep that line or not, and if I keep that line, then I yield it out, otherwise I don't. You can see here I'm using a generator. I could use just a regular list that returns or use a regular function that returns a concrete list, but you get the idea of why the generator might be a little bit helpful here. It's less presumptuous in terms of how much of this data I'll eventually want to store. And when you look at this looping logic, you can see this is actually pretty clean. I have my data, I open up my file, my data directory, I open up my file, I go through each line of this, skipping the headers, and I do my transformation. But where you should always think about modalities when you think about reporting is, I have eliminated your control of a modality. Fundamentally, what reports are often about is preserving modalities for somebody to come back to you later and say, I actually didn't want to take that choice. I want to take the other choice. And here, this code with this skip headers iteration helper presumes what you want to do with the headers. It presumes you want to skip them. It presumes you never want to look at them and you're not going to use them for anything else. But you could think, well, there are actually some things I could do with these headers. I could use them to figure out if there's a column reordering. I could use them to name my columns when I create some structure. Maybe I could use them to create a named tuple, and I could have the fields automatically named. So this is a little bit more flexible if the column names happen to change later, but I don't really care about, but they don't necessarily affect how I parse the data. And I've eliminated with this iteration helper the ability to make that choice later. Generally, when we think about iteration helpers in Python, what we should be thinking about is how do we lean into how Python wants us to write code to supplement looping with additional information to preserve our later ability to make different choices. And the idea of modalities and the idea of writing better reports by paying attention to where modalities might appear is all about keeping in mind where might somebody want to make a different choice, and I want to preserve their capability of making that different choice, and I want to preserve that at the most superficial level of my program, so I do not have to revalidate any library code or any data loading code or any code that somebody else might have a dependency on. And so rather than write a skip headers iteration helper, it's probably a much better idea for me to write a mark headers iteration helper that just marks that this is a header or not, and allows me to decide later on if I don't want to skip these, but I want to do something else with these. Here you can see it's still done the extraction, but you can actually see that it'll print out, the header line here. This comes up quite a bit when we're talking about things that are, or when we're talking about reports, we need to look at deltas. So here's a different data set where I have some time series and I have some measurement captured at each date. And what I might want to do in printing out this report is print out the date, and I might want to print out it went from 4 to -10, from -10 to 19. The delta between these would be whatever the current value is minus the previous value. And if I needed to write this to eliminate any noise that might be in my looping body and to really keep my looping body very clean, then I might make use of something like itertools.pairwise or one of my favorite iteration helpers that I've written for you from memory across many of these sessions, nwise. And you can see when I do something like nwise, I can say, I'm going to loop over the previous value and the current value. I'm going to loop over the previous date and the current date, and I'm going to print these out. And what you can think here is I've taken something that I'm iterating over, some elements of my report, some records, some lines, whatever you might want to call them, entries, if that's what you prefer, and I'm supplementing the looping with additional information that allows me at the superficial most level of my program to decide what to do with that. For example, to use that information to compute something new, like the delta of how this data changes. Now, one thing that you can see here is these dates are not contiguous. So maybe one addition to this report that somebody asked for is, tell me how many days for each line item are between this line item and the next one. So here this would be 1 day following up. Here this would be 1 day. Here this would be 2 days following up, 2 days following up, and 1 day following up. And so maybe it's the case that I want to have something that looks a little bit in the future and something that looks a little bit in the past, compare the current value against the previous value, and compare the current date against when the next date would be. And this is where the idea of iteration helpers goes even deeper. You've seen me do this before, writing things like ny's longest, first, and last, where the goal of this is to take some looping that I have, to supplement it with some additional information, to supplement it with some information about a modality, to expose that at the superficial most level of my program, to make a decision based off of this. So what I'm going to do is I'm going to loop over pairs of this data of size 3, so I get each current value, the previous value, and the next value, and to identify, am I looking at the very first value? Am I looking at the very last value? So that I can take some report that gives me the date, the value, how many days are for the next signal, what the delta is, and if I'm at the very top of the report, I can make sure to print something out special there. There is no delta. If you do a pandas.series.shift, you get a nan there. There's no previous value, so there's no comparison there. And if I'm at the end of the list, I get some missing data here. Well, I don't know when the next signal is coming in. This is where my data ended. And I can do this in such a way where the body of this loop allows me the flexibility to later come in and be responsive to changes. They ask for something else on this data. For example, oh, tell me how this changed year over year. Maybe I would update my iteration helper to give me a window a little bit larger, maybe a window not of size 3, but a window of size 365. So I could look back in time and do a year-on-year value. Now, of course, for daily data, that's going to be a little bit hard, but maybe you can think maybe week-on-week data might be a more appropriate example. Lastly, I want to talk about how does the itertools module support better reporting. You can see when we write iteration helpers, we're often making use of the itertools module to take small building blocks and to build them up into more helpful tools that expose certain modalities. Well, one of the things that I want you to think about when you think about reporting is a lot of reporting comes down to something that you might very informally call scenario analysis. Scenario analysis is the idea that it's not just looking at a summary of the data, but it's often about looking at the data that you have and then running scenarios against the data to see how that data changes. And you can think that this is often going to be the case if you have something that you can maybe compute that's not simple and linear, that doesn't have maybe an easy closed form solution, where you might want to tweak a couple of scenarios and then see how they affect something. And you kind of want to run through those scenarios and report, under this scenario, this is what we see, under this scenario, this is what we see, under this scenario, this is what we see. Well, we can think a scenario is basically a Python dictionary, right? It's some label and then some information about what that scenario contains. And so Python leads us very nicely to, whenever we're doing some kind of scenario analysis, we're probably modeling this as something like a dictionary. Here we have 3 scenarios for high, medium, and low growth, for some income and some cost, for some revenue and some costs, and we can see that our report gives us these 3 scenarios. Well, what if it's the case that we have a different growth factor for both the income and for the costs? Well, then we expand our modeling here. We might say this is the income growth and this is the cost growth, and you can see where the low growth is actually pretty disastrous because our costs grow much faster than our income grows. And you can see we can run through this scenario as well. But it's often the case when we're doing scenario analysis that we want to look at combinations of scenarios. Here are all the scenarios for our income. Here's all the scenarios for our cost. Maybe we want a double for loop so we can say, under this income scenario and under this cost scenario, this is what the profit looks like. And then we can say, okay, you know what? If we have low income growth and high cost growth, that's really taking us to a place where the investors are going to complain. But otherwise, for the most part, as long as we're up here, the investors may not be that happy, but they're not going to complain that much. And when we look at the itertools module is full of these tools that allow us to perform iterations more cleanly, more concisely. Things like itertools.product that allow us to do this double looping in such a way that we don't actually have to have a double loop. We just do the Cartesian product of all of the income scenarios against all of the cost scenarios. And you might say that's kind of a trivial example. You just took 2 layers of a for loop and put it into 1 layer. But I want to introduce one micro piece of vocabulary here, the idea of visibility. One of the things that the itertools module allows us to do is it allows us to take loops, and it allows us to take the thing that we're looping over and to break it up into parts that allow us to insert visibility in the middle. Let me show you what I mean. Let's say it's the case that there are certain scenarios we do not want to consider. And we don't want to consider those scenarios because they're not realistic. Somebody has looked at this and said, you know what, there's no chance that we'd have both high growth of the income and low growth of the costs. It's always going to be some combination of these, and there's only a subset of these that we actually need to investigate based off of some other analysis that's happened. We could, instead of directly looping over these, use itertools.product to construct what the scenarios would look like, eyeball that. Let's see what scenarios we're going to run. Okay, those are all the scenarios we're looking at. And then maybe do some filtering, look at those scenarios again. Okay, those are the scenarios that are left, and then apply our report to the scenarios that are left. Visibility is an important characteristic of good reports because they allow us to interject at any point in the code something that allows us to say, is this doing the right thing? Is it looking at the right data? Is it looking at the right scenario? And the itertools module leans into this very nicely because if it were the case that we had some complex scenarios that we wanted to exclude, maybe we want to make it very easy for somebody to visibly see what the excluded scenarios were. Oh, we exclude the high income growth, low cost growth scenario. Okay. And to understand what the resulting report looks like. Similarly, if we had some events that we were worried about, like events A, B, and C, one event is we lose a factory that we had a bid out on. The other one is we lose a client. We might use something like itertools.combinations to look at all the combinations of two events, or chain.from iterable with itertools of combinations to look at all of the events that could happen, and then to run one report for each one of these scenarios. We can use the itertools module to construct the scenarios, visibly identify, okay, those are the things that we're going to run our analysis on, and then actually apply that to the report.